Hello everyone, welcome to Infostonsystems training channel. This is David. So we are on the topic of semiconductor series. This is the 5th episode. Last episode, which was 4th episode, we talked about doping technologies that will make silicon conductive. If you haven't watched 4th episode, please go ahead and watch and come and watch this episode. Then you would get a better understanding. Let's go to the topic. So in this episode, we're going to talk about type of transistor, and we're going to talk about how this doping technology make the transistor operate. So let's see the type of transistor. So there are two type of transistor that widely used in the world. First one is BJT, that is bipolar junction transistor. This kind of transistor majorly used in communication equipment where we need to boost the signal, means amplifiers and radars and the military equipment. So this kind of areas, this BJT is widely used. And another one is MOSFET transistor, that means Metal-Oxide-Semiconductor field effect transistor. This MOSFET transistor is widely used in modern electronics, like the smartphone we are using, the computers we are using, laptop we are using. These kind of devices, the MOSFET is widely used. So in this episode, we're going to talk about MOSFET transistor because that everyone must understand. So MOSFET transistor has two different types. One is N-type MOSFET transistor. It is also called NMOS, and P-type transistor, it is also called PMOS. So N stands for negative, P stands for positive. Okay, we already seen the MOSFET transistor structure. MOSFET transistor had three different parts that we have seen in the second episode, right? First one is source, second one is gate, and third one is drain. So for N-type transistor, source and drain used with N-type silicon, for gate used with P-type silicon. Vice versa for P-type transistor in MOSFET, source and drain used with P-type silicon and gate used with N-type silicon. So we already know to make the silicon to carry the negative charge, we have to dope the silicon with phosphorus, and to make the silicon to carry the positive charge, we have to dope the silicon with boron. So for N-type transistor, source and drain used with boron doped silicon because that is we need to have silicon to carry the negative charge. For gate to be doped with boron because we need that has to carry the positive charge. We already know if any element has extra holes that carry the positive charge, any element has extra electrons that carry the negative charge. So let's talk about deep into the N-type transistor. For N-type transistor, as I told, right, source and drain is N-type silicon, and channel is gate is P-type silicon. So before we going to see the mechanism behind this transistor, we should know how gate works. So the gate also has three different types. So gate, then next one is gate insulating material, and third one is channel. The gate is made up of highly conductive material and the channel is made up of silicon. In between both there is a insulating material. For N-type transistor, the gate is made up of same like conductive material, any conductive material, like think about copper, whatever you think. The second one is highly insulating material. The third one is channel. The channel is made up of boron doped silicon because it's N-type transistor, right? So when you give positive voltage to the gate, so what happens means it will change the behavior of the channel. What exactly happens is when the gate receives the positive voltage, it will repel the channel because channel is made up of positively charged carrier. So that the channel, right? So because in childhood, you know that, just best example, we already played with magnet, right? So what we do, like we know that same direction of the magnet, it will repel each other, but opposite direction attract each other. Same concept here. When the gate receives the positive voltage, it will repel the channel, because channel is made up of positively charged silicon, means it has extra holes. So repel means what? It will push the hole away, means there is a the bridge will be created. So means when the gate receives the voltage, that will create the electric field that will make the inversional layer, which means that temporarily the channel will be converted to n-type silicon, because it pushes the hole away. So which means what? The electron can freely move, so that will be converted to the n-type transistor. So but we already know source and drain already n-type silicon, so which means what? That gate will attract both of them. So which means that current from the source flow from source to drain through the channel. So the channel will act like a bridge, because as long the inversion layers appear, the channel will act as n-type silicon, so which means that allow the current flow from the source to drain. So as soon as you cut off the current from the gate, the inversion layer will disappear the same way, then the gate also will turn back to original state, that means positive based silicon. Vice versa, same like the p-type transistor works. For the p-type transistor, instead of you giving a positive voltage to the gate, you would give a negative voltage, right? So because we already know for p-type transistor, the channel is made up of phosphorus doped silicon, because we need silicon to carry the negative charge, means it has extra electrons. When you give the negative voltage, it will repel, means it will push the electron away. So that inversion layer means electric field will make the inversion layer that will attract the electron from source and drain, because source and drain made up of positively charged silicon. So the gate is negative, the source and drains are positive, some opposite directions, right? Then it will attract each other. So means that gate will act as a bridge. It will allow the current, means holes from source to drain, means the positively charged carrier current will flow from the source to drain. This is what how that p-type transistor works. So let's simplify this. For n-type transistor, you have to give the positive voltage to the gate, that will allow the current flow from the source to drain through the channel. For p-type transistor, you have to give a negative voltage, that will allow the current flow from the source to drain through the channel. So we already know like how the transistor works now. So now we have a better understanding, right? So in the next episode, we're going to talk about how we can programmatically control the transistor. So that will give you the better understanding, right? So until then, stay tuned. Thank you.